Have you ever truly looked at a tiny ant crawling right beside your feet while walking? Probably not, because the human eye evolved to see the big picture, not the details, to understand the world around us. We notice trees, mountains, the sky, and human faces. But right beneath our feet, an invisible world, almost as alien as another planet, sustains life. A world where a dewdrop is a vast lake, a blade of grass a skyscraper, and a flower petal a colorful continent stretching for miles. Creatures that are almost imperceptible to us struggle to survive in their own world amidst enormous obstacles, predators, and natural disasters. What's interesting is that even though we see them every day, we hardly know what they actually look like. The human eye struggles to discern details smaller than about half a millimeter. Therefore, much of nature's most fascinating detail remains invisible to us, even though it's right in front of our eyes. This is where macro photography comes in. Macro lenses don't just magnify the image, they reveal another reality beyond our reach. The first time you look closely at a fly's eyes, you realize it doesn't have just one. This extraordinary structure, composed of thousands of tiny lenses, perceives the world around it from different angles simultaneously. When you approach a bee, you don't just see its yellow and black stripes, you discover that its entire body is covered in fine hairs specifically designed for collecting pollen. While a spider's face appears as a tiny black dot from a distance, in macro images, its 8 eyes transform it into a flawless hunter straight out of a science fiction film. A butterfly's wings are not just colorful, they are a complex engineering marvel composed of millions of microscopic scales. Every detail is the result of millions of years of silent but flawless evolutionary work. Nature builds nothing randomly. Even the smallest living things contain extraordinary design. In fact, the true rulers of the Earth are not elephants, lions, or whales as we might think. The real owners of our planet are insects. Scientists estimate that there are approximately 10 quintillion insects living today. This number is so large that there are more than a billion insects for every person on Earth. Moreover, insects make up the vast majority of animal species identified to date. For millions of years, they have managed to adapt to almost every corner of the Earth, surviving in nearly every environment, from deserts to rainforests, from the poles to mountain peaks. But if we truly want to understand them, we must first descend to their size. Now imagine, you suddenly shrink. Your height is only a few millimeters. The grass that seemed ordinary just moments ago now transforms into giant trees reaching towards the sky. The tiny grains of sand on the ground rise like giant rocks that must be overcome. Even a light breeze feels as powerful as a devastating storm. A drop of water stretches out before you like a vast lake. Just then, a silently walking ant appears before you. But you no longer see it as it once did. With its shiny black exoskeleton, perfectly functioning joints, constantly moving antennae, and incredible coordination, it resembles a miniature robot. In a matter of seconds, it analyzes its surroundings, determines its direction, and continues on its way. Yet, this extraordinary creature was just one of hundreds you passed by without noticing a few minutes ago. Throughout this journey, every living thing you see will be the very same things you encounter every day but never truly see. When the doors to the macro world open, nature takes on a completely different identity. Every seemingly simple surface is covered with complex patterns, every ordinary living thing transforms into an extraordinary feat of engineering, and tiny lives suddenly become the setting for colossal adventures. Perhaps the greatest discoveries in the universe are not in distant galaxies, but hidden just a few centimeters beneath the very ground we walk on every day. Now it's time to readjust our gaze. Because the world you are about to see will be the very world you have ever looked at but never truly seen. The first thing that catches your attention when you take your first step into the macro world is how complex insects appear. From a distance, these creatures look like mere small black, brown, or green dots, but upon closer inspection, they resemble biological machines, the product of millions of years of engineering. No surface is perfectly smooth. Every millimeter is covered with protrusions, grooves, hard plates, and perfectly interconnected joints. Human skin is soft and flexible, it can be scratched or injured by the slightest impact. In insects, however, the situation is completely different. Their exoskeleton, which protects their bodies, is made of an extremely durable substance called chitin. Chitin is lightweight yet extraordinarily strong. Thanks to this, insects can both protect their bodies and maintain their mobility while continuing to live. If you look closely at an ant, you will see that the delicate joints connecting its thorax, head, and abdomen work in perfect harmony. Each step is accomplished by the synchronized movement of dozens of muscles. Even the most advanced man-made robots have not yet been able to achieve the efficiency of these natural systems. Moreover, these tiny creatures don't just walk, they climb, dig, carry loads, and, when necessary, fight opponents many times their own size. Perhaps one of the most astonishing examples is ants. A worker ant can easily carry loads tens of times its own weight. If humans had the same ratio, we would be strong enough to lift a large truck off the ground by ourselves. The secret to this incredible strength lies not in the size of their muscles, but in their small bodies. As creatures shrink, the ratio of muscle strength to body weight increases, giving them an unexpected advantage. In macro shots, the jaws of ants also reveal remarkable details. In some species, these jaws function like sharp scissors, while in trap-jawed ants, they close in a fraction of a second, performing one of the fastest movements in nature. The speed at which the jaws close is so high that some ants can use this force not only to catch prey but also to launch themselves into the air in times of danger. Another engineering marvel is hidden in the feet of insects. The ability of a fly to walk comfortably on the ceiling has puzzled scientists for many years. Thanks to macro images, it has been discovered that there are millions of microscopic hairs on the soles of their feet. Even smaller structures at the tips of these hairs allow them to cling to surfaces by utilizing weak attractive forces at the molecular level. This is why a fly can easily move on glass, ceilings, and even seemingly perfectly flat surfaces. Similarly, the same physical principles underlie the climbing ability of geckos. Nature has repeatedly developed the same solutions in different creatures. Even the colors on insects' bodies are not merely aesthetic. Some blend in with their surroundings to hide from predators, while others announce their venom with their bright colors. The ladybug's red color and black spots are a clear warning to birds, "Don't eat me." These colors are a silent language of communication that has developed over millions of years of evolution. In macro shots, the complexity of these patterns becomes even more apparent. Every line, every scale, and every protrusion serves a specific purpose. There is no room for unnecessary details in nature. Energy is extremely valuable, and evolution eliminates useless features over time. Only the most efficient solutions remain. That's why every structure you see on a tiny insect is a flawless design that has been tested and survived countless times over millions of years. Human engineers today are still studying these miniature creatures to develop lighter aircraft, stronger armor, more efficient robots, and more durable materials. Because sometimes the technology of the future is not in laboratories, but hidden in the body of a millimeter-long ant silently crawling on the ground. And this is one of the first great lessons the macro world teaches us. Nature's greatest engineering achievements are often hidden in the smallest creatures. So far we've examined the bodies of insects, but one of their most impressive features is undoubtedly their eyes. Humans see the world with two eyes, and our brains combine these two images to create a single three-dimensional image. Our eyes are quite good at picking out details, but we have limitations when it comes to perceiving motion. However, the rules are completely different in the world of insects. When you look closely at a fly, you realize that its eyes are not actually a single piece. This structure, made up of hundreds, even thousands, of tiny hexagonal lenses, is called a compound eye. Each lens sees only a small part of the environment. The brain then puts all these images together to create a giant mosaic. Therefore, instead of focusing on a single point, a fly can perceive movements happening around it from almost every direction simultaneously. That's why, no matter how slowly you extend your hand, it will often have already flown away before you can touch it. Because what is slow for you is quite significant for its nervous system. The insect's visual system not only provides a wide field of vision but also causes them to experience time differently than we do. Scientists call this temporal resolution. While the human eye can distinguish a certain number of images per second, many insects can perceive images changing at much higher speeds individually. In other words, events that we see as a single, fluid movement may unfold like a slow-motion film for them. This ability allows them to evade predators and capture their prey with extraordinary precision. In macro shots, the eyes of dragonflies, in particular, offer a fascinating sight. These enormous eyes, which cover a large part of their heads, can consist of approximately 30,000 tiny lenses. With a field of vision of almost 360 degrees, a dragonfly can even detect many movements happening behind it. Thanks to this superior vision, it has become one of nature's most successful hunters. Studies show that dragonflies catch their prey in the air with a success rate of over 90%. This rate is even higher than many large predators. But the world that insects see is not only wider than ours, it is also more colorful. The human eye can perceive red, green, and blue wavelengths. Bees, however, can also see ultraviolet light. This means that a flower, which we see as completely dark or monochrome, is covered with glowing directional markers for them. The patterns on the petals of flowers, invisible to the human eye, guide bees directly to the center where the nectar is located. Nature has developed a silent but flawless communication system between plants and pollinators over millions of years. When we can see these hidden patterns thanks to macro cameras and special imaging techniques, we realize that even the flowers we thought we knew actually have a completely different appearance. Some butterflies can not only see colors but also find their way by sensing the polarization of sunlight. This ability acts as an invisible compass for them during their long migratory journeys. Human technology has still not been able to replicate all of these natural sensory systems possessed by insects. The eyes carried on the heads of tiny flies, bees, or dragonflies continue to be a source of inspiration for modern cameras, motion detection systems, and artificial vision technologies. Perhaps one day the autonomous vehicles, drones, and intelligent robots we use today will become far more advanced thanks to the working principles of the insect eyes we admire so much today. Because the closer we get to the macro world, the more we see that nature is not only beautiful but also full of cleverly designed solutions that will shape the future of humanity. And every new detail of this unseen world teaches us something new about our own world. Some of the most fascinating colors we see in nature are actually colors that don't exist at all. This may seem impossible at first glance. After all, if a butterfly's wings appear blue, we assume it has a blue pigment. However, when the doors to the macro world are open, the truth tells a completely different story. The bright blue, green, or metallic tones we see on the wings of some of the world's most impressive butterflies are not created by paint. Most of these colors result from the interaction of light with microscopic structures. When you zoom in on a butterfly's wing with a macro lens, instead of seeing a smooth surface, you encounter an extraordinary architecture composed of millions of tiny scales. Each of these scales is a complex structure stacked on top of each other like tiles. On closer inspection, it becomes clear that these scales have nanometer-scale ridges, grooves, and layers. These invisible structures refract, reflect, and scatter light from the sun at different angles. As a result, our eyes perceive dazzling colors that are not actually physically present but are created by the behavior of light. Scientists call this phenomenon structural coloration. Therefore, it's no coincidence that a butterfly's wing appears to change color when viewed from different angles. As it moves, shades of blue can transform into purple, turquoise, or green. It's as if the wings are alive and breathing with the light. Nature developed this millions of years ago. Humans, however, are only just beginning to understand this extraordinary optical system. Today, the microscopic structure of butterfly wings is inspired by many areas, from anti-counterfeiting security strips and color-changing car paints to advanced optical sensors and next-generation display technologies. But colors aren't just for beauty. For many butterflies, colors are key to survival. Some species announce their poisonous nature with their bright patterns. Birds and other predators learn to associate these vibrant colors with danger over time and stay away from them. This is called warning coloration. Other butterflies do the opposite. When they close their wings, they blend seamlessly with a dry leaf, tree bark, or a moss-covered branch. Macro images clearly show how incredible this camouflage is. The veins on the wings mimic leaf veins, while small spots resemble fungal growths or decaying tissue. In some species, even the irregular ridges on the wing edges resemble weathered leaves left in the sun for years. A predator, even from a few centimeters away, cannot see the butterfly because its brain interprets the image as just an ordinary leaf. Evolution, over millions of years, has rewarded not only creatures that run faster or are stronger, but also those that can hide better. Some butterflies use optical illusions for defense. The large circular patterns on their wings, when viewed from a distance, resemble the eyes of an owl or a larger animal. When they unexpectedly spread their wings, the predator is startled for a brief moment. This few seconds of surprise is enough for the butterfly to escape. Thanks to macro photography, we realize that these patterns are not just random spots, but highly symmetrical and carefully arranged structures. Nature has not only produced color but has also successfully used optical illusions for millions of years. However, the lifespan of butterflies is not as long as we might think. Many live for only a few weeks. In this short time, it must feed, find a mate, reproduce, and evade countless predators. Every scale, every pattern, and every shade on its wings is a silent part of this arduous struggle for survival. When we see a butterfly, we only see an elegant creature. However, when we look through the window of the macro world, we encounter nanotechnological structures that control light, flawless camouflage systems, advanced defense strategies, and an extraordinary work of engineering shaped by millions of years of evolution. Perhaps the greatest artist of nature was never humankind, because the most impressive color paintings were not painted with a brush, but with light itself, and on butterfly wings only a few micrometers thick. And we can only truly see these invisible works of art when we get close enough. When we look at a flower, we usually see beautiful colors, pleasant scents, and elegant leaves. For us, flowers are one of nature's most aesthetically pleasing elements. However, if we could see them through the eyes of a bee, we would encounter a completely different scene. Because flowers didn't evolve solely to be beautiful for humans. Their primary goal was to attract the right pollinators to visit them. Therefore, an extraordinary partnership developed between plants and insects over millions of years. Hidden signals emerge that we cannot see but bees can easily detect. The human eye perceives visible light ranging from red to purple, but bees can see beyond that. Ultraviolet light is a natural part of their world. That's why many flowers that we see as completely yellow or white are actually covered with bright patterns extending towards the center for bees. These patterns act like runway lights at an airport, guiding the bee directly to the nectar source. When macro cameras and special filters are used, these hidden patterns become visible for the first time. Suddenly, seemingly ordinary daisies, sunflowers, or wildflowers transform into living maps filled with complex geometric shapes. Every line, every loop, and every contrast carries the silent messages of millions of years of shared evolution. But the most important treasure of flowers is neither in their petals nor in their colors. The real treasure is in the tiny pollen grains that are barely visible to the naked eye. Pollen, which appears as the yellow dust that gets on our hands in daily life, takes on a completely different identity under a macro lens. Each one resembles a miniature sculpture from another planet. Some resemble spherical structures covered with thorns, some are adorned with honeycomb patterns, and some have a star or net appearance. What is interesting is that no pollen grain is completely randomly shaped. Each plant species has its own unique pollen design. Scientists can determine which plant a pollen grain belongs to simply by looking at its shape. In fact, thanks to fossil pollen found in sediments dating back thousands of years, they can even understand which plants lived in the past and what the climate was like. In short, these microscopic structures not only enable plant reproduction but also silently record the history of the Earth. When bees land on a flower, they don't just collect nectar. Thanks to the fine, branched hairs covering their bodies, pollen sticks to them. The slight electrostatic charge generated during flight helps these pollens adhere more easily to the hairs. When the bee lands on another flower, some of this pollen is transferred to the new flower, and pollination occurs. This process works so perfectly that most flowering plants on Earth owe their lives to these tiny creatures. In fact, many of the fruits, vegetables, and nuts we eat are also the result of this same invisible collaboration. Apples, cherries, strawberries, almonds, pumpkins, and countless other agricultural products grow thanks to bees and other pollinators. A bee's seemingly ordinary, short journey from flower to flower forms one of the most important links in humanity's food chain. Macro shots reveal this journey in incredible detail. When you watch a bee extend its proboscis deep into the nectar, how pollen grains cling to its individual hairs, and how its wings flutter hundreds of times per second, balancing in the air, you gain a better understanding of how delicately balanced nature is. But this perfect system is not guaranteed forever. Pesticides, habitat destruction, climate change, and environmental pollution are rapidly reducing the numbers of many pollinator species. The disappearance of a bee doesn't just mean the disappearance of a single insect, it means the breaking of a vast chain that affects hundreds of flowers it visited, the creatures that fed on those flowers, and ultimately, humans. This is one of the most important truths the macro world shows us. Sometimes the fate of an ecosystem depends on a few barely visible pollen grains reaching the right place. Every flower silently sends a message, every bee reads this message, and every flight completes the cycle of life that has continued for billions of years. We often don't notice this, but when we get close enough, we realize that nature's greatest miracles are hidden in the smallest details. From a distance, we see colorful flowers, shimmering butterflies, and seemingly peaceful nature in the macro world. However, upon closer inspection, we realize that this quiet world is actually the scene of a relentless struggle for survival. Here, every second a hunt begins, every moment, as one creature tries to escape, another moves to catch it. One of the most impressive predators in this world is the praying mantis. Although its long front legs may seem to be praying, they are actually one of the fastest catching mechanisms nature has developed. A praying mantis can wait for hours with almost no movement. It sways gently like a branch swaying in the wind, completely blending into its surroundings. When its prey gets close enough, everything changes in an instant. Its front legs dart forward in a fraction of a second, and its powerful arms, covered in sharp spines, grip its prey in a way that prevents escape. This movement is almost imperceptible to the human eye. However, thanks to high-speed macro cameras, we can see in detail how precisely and flawlessly this attack is planned. The praying mantis's ability to turn its head almost 180 degrees also gives it a great advantage. While most insects can only see in certain directions, this one constantly scans its surroundings, detecting even the slightest movement. Another master hunter is the jumping spider. Most people think of spiders only as web-spinning creatures, but jumping spiders use a completely different strategy. They patiently pursue their prey, carefully calculate the distance, and when the right moment arrives, make a single leap many times their own body length. In macro images, the large eyes located at the front of their faces immediately catch the eye. These eyes give the spider an extraordinary sense of depth. In fact, scientists believe that some jumping spiders calculate the distance like a sharpshooter before attacking their prey. Once close to their prey, there is no turning back. A single leap either results in success or the prey escapes forever. One of the most successful hunters in the sky is the dragonfly. This extraordinary insect, which has lived on Earth for approximately 300 million years, has a history even older than the dinosaurs. It has one of the highest success rates among creatures that hunt in the air. Studies show that over 90% of dragonfly attacks are successful. This isn't just because they fly fast. Their brains act by calculating not the location of the prey, but where it will be a few milliseconds later. In other words, they don't chase their prey, they predict its future position. This ability is being studied as one of the biological solutions that inspired modern missile tracking systems. In macro shots, it's possible to see that their four wings move independently of each other. This allows them to hover in the air like a helicopter, suddenly fly back, change direction in seconds, and perform incredible maneuvers. But this invisible battle isn't limited to large predators. Even a ladybug isn't as innocent as we think. This small creature, which we see as a charming symbol of gardens, is a truly feared predator for aphids. A single ladybug can consume thousands of aphids in its lifetime. Similarly, the larvae of lacewing insects are also extremely effective predators of plant pests. Different hunting strategies have developed in every corner of the macro world. Some use speed, some camouflage, some venom, and some patience. But they all have one common goal: to survive another day. Interestingly, the race between predator and prey never ends. When an insect learns to escape faster, its predator develops new ways to catch it. When a butterfly becomes better camouflaged, the eyes of the birds that hunt it develop to detect this camouflage. Evolution is a silent arms race that has been going on for millions of years. Neither side can remain superior forever. Every advantage eventually leads to the emergence of a new counter-strategy. Macro cameras not only provide us with impressive images, they also reveal the most fundamental law of nature: survival. There is no cruelty here, no evil. Only a perfect balance that works to ensure the continuation of life. The success of one predator means the end of another, while simultaneously ensuring the survival of its own offspring. In this unseen world, every movement has a reason, every behavior has a history spanning millions of years. We often watch a small insect flying in our garden for only a few seconds before moving on. Yet, in those same seconds, epic chases unfold in details beyond our sight, flawless plans are executed, and nature's oldest struggle continues unabated. This is one of the greatest surprises of the macro world. The life of the smallest creatures is far more complex than we imagine. At the beginning of this journey, we chose only to look more closely. But now, we know that the world is actually much larger than we thought. Because size isn't always measured in kilometers. Sometimes, an area of a few centimeters can be as complex as a boundless universe waiting to be explored. The serene landscape we see while walking on a patch of grass transforms into a completely different reality when viewed through the window of the macro world. The grass is no longer tiny plants, but giant forests stretching towards the sky. Dewdrops are no longer small droplets of water, but like lakes with shores. Even a single grain of sand on the ground becomes a giant rock to be overcome. This is the world where insects, spiders, and countless other small creatures spend their entire lives. For them, every journey is a great discovery, every obstacle a mountain to be climbed, and surviving each day is an extraordinary achievement in itself. But the most impressive aspect of this invisible world is not just the change in our perception of size. What is truly fascinating is that every living thing here is connected to one another by invisible bonds. A flower visited by a bee is the beginning of a fruit that will later develop. That fruit nourishes a bird. The bird carries the seeds miles away. New plants grow, protect the soil, produce oxygen, and create habitats for other living things. Aphids hunted by a ladybug keep plants healthy. Flies caught by a spider maintain the balance of insect populations. An ant aerates the soil while simultaneously carrying plant seeds to new habitats. Every seemingly insignificant action is actually a link in a giant chain that ensures the continuation of life. When a single link in this chain breaks, its effects can spread throughout the entire ecosystem over time. That's why there is truly no insignificant creature in nature. For many years, humanity has admired large animals. We watched the strength of lions, the flight of eagles, the size of whales. Yet, the real heroes that form the basis of life were often so small that our eyes couldn't perceive them. They cultivated the soil, propagated plants, decomposed organic matter, maintained nutrient cycles, and kept Earth a habitable planet for millions of years. They became the silent engineers working without our noticing. Macro lenses not only gave us beautiful images, they also changed our perspective. A tiny piece of leaf carried by an ant no longer seems ordinary. A spider web isn't just a simple trap made of fine threads. A butterfly's wings don't just carry colorful patterns. A bee landing on a flower is more than just a brief visit. We now know that behind every detail lies millions of years of evolution, extraordinary engineering, and perfect balance. Perhaps after watching this video, you will never look at nature the same way again. Perhaps one day, while walking, a tiny ant will catch your attention. Perhaps you will look a few seconds longer at a spider web shimmering in the morning sun. Perhaps you will remember that the colors on a butterfly's wings are actually a play of light. Or, while watching a bee silently move among the flowers, you will think that it is not only collecting nectar, but shaping the future of an entire ecosystem. Science doesn't just give us new information. It also teaches us to rediscover the things we take for granted. The macro world does exactly that. It makes visible the details that our eyes see every day but our brains often overlook. And it reminds us that the greatest wonders of the universe are not always in distant galaxies viewed through telescopes. Sometimes the greatest discovery is to look a little closer at the ground beneath our feet. Because the true magic of life is often hidden in the smallest details. In a drop of water on the shore, in the heart of a flower, in the delicate threads of a spider's web, or in the silent steps of a tiny ant. Nature tells us countless stories every day. But to hear these stories, we must first slow down, and then learn to truly look. Perhaps this is the most valuable lesson the macro world teaches us: you don't have to be a giant to be great. The most important lives that change the world are sometimes so small that they are barely visible to the naked eye. And as we get closer to them, we begin to understand not only them, but also the planet we live on and ourselves better. If we have been able to open a window to this invisible world together today, look a little more carefully at the ground on your next walk. Because perhaps the most impressive documentary of your life will be silently unfolding right under your feet at that moment.